So final part of chapter 21 is going through this last type of question, which is where you're given the heats of formation of reactants and products in an equation, and you have to calculate the heat of the reaction. So that's what this question is. You have another example on page 380 of your textbook if you want to have a look through that as well. I'll be going through the same steps here. So methanol burns in oxygen according to the equation given on the screen, and you must use the heat of formation of the three equations given to you to calculate the heat of combustion of methanol. So the heat of combustion is the change when 1 mole of the substance completely burns in oxygen. So step 1 is our required equation, which is the equation for the combustion of methanol. Now, sometimes you'll be asked to work this out yourself. In this case, they've given you the equation for methanol burning in oxygen, but what they haven't given you is the correct one that you need for this calculation, because as we just said, the heat of combustion is when 1 mole of a substance is burned in oxygen. Here we've got 2 moles. So we need to divide this by 2 to get the heat of combustion equation. So that's going to give us CH3OH, that's terrible writing, let's try again, CH3OH plus 1.5 oxygens is going to give us carbon dioxide and 2 waters. And our delta H for that is our question mark. That's what we're trying to find out. So the next couple of steps are trying to form this equation, the orange equation, from the 3 equations that we're given. So what can we do here? We've got carbon, oxygen and carbon dioxide, and what we're going to do is look at the reactants and products that we have here, and we do have a carbon dioxide. As we said in the last video, you've got oxygen as a factor in all of them, so we don't tend to try to balance the oxygens. That can be our test for if we're correct at the end or not. If our oxygens don't come out, if we're finished this and we don't get 1.5 oxygens, we know we've gone wrong somewhere when we put all our equations together. So for now we're working on reaction A there, and what we need from it is we need to have 1 carbon dioxide on the right hand side, and that's exactly what we've got. So step 2, in sorting out our carbon dioxide reaction, I'm going to write RXN for reaction. Reaction A stays the same. Now we did this separately last time, but if it stays the same, we can then say that the delta H for that must stay the same as well, minus 394. The next one we're going to look at is reaction B, and the one that's telling us about is our waters, so H2O and H2O. Now in the equation for what we want, we've got 2 waters there. So that means that for our water, for our 2H2O, we're going to have to do reaction B times 2. And that's going to give us 2H2 plus O2, giving us H2O, 2H2O. And the delta H for that is, if we multiply the equation by 2, we have to multiply the delta H by 2. So it's 2 times minus 286, which gives us minus 572 kilojoules per mole. And finally, the last equation, so like we said, we're skipping oxygen. So the last equation, we must need to sort out our methanol. So you can see from the equation that we're given that methanol is on the right, and for a required equation you can see that methanol is on the left. So how we sort that out is we are going to flip the equation C around. So for step 4, we are going to have to reverse equation C. That's not how you spell reverse. Reverse equation C. And so what that's going to look like is you're going to get CH3OH. H's are terrible. Creating carbon, 2 hydrogens, and a half oxygen. And because we have flipped the equation around, we're going to change the sign on the heat of reaction, or the heat of formation, sorry. So it's going to be plus 250 now. So they are our 3 equations that we're going to use. Reaction A has stayed the same to give us 1 carbon dioxide on the right. Reaction B, we have doubled to give us 2 hydrogens on the right. And reaction C, we have reversed to give us our methanol on the left. So now looking at that, we need to put them all together to get our final reaction. So if we go through this, we have got from reaction A, first of all, we've got carbon plus oxygen. Carbon plus oxygen. From reaction B on the left hand side, we've got 2H2 plus O2, plus. And from reaction C, we have got plus CH3OH. And then on the right hand side, we're adding all of that together as well. From reaction 1, we've got carbon dioxide. From reaction 2, we've got plus 2H2O. And from reaction C, we have got plus carbon, plus 2 hydrogens, plus a half molecule of oxygen. And so what we need to do now is tidy that up. So what we can do, we can cancel out the 2 H2s on the left and the right. We can cancel out the carbon on the left and the carbon on the right. We can cancel out this half oxygen. We can cancel that out with half of this, so that we're left with a half oxygen there as well. And that should give us, if we rewrite what's left now, that should give us our orange equation up here. So we have got CH3OH plus 1.5 O2. What have we left on the right? We've got carbon dioxide plus 2 H2O. And if you compare that to the orange equation above, you'll see they're identical. So we've balanced those correctly. Now the last part of this is working out the delta H value for that. So delta H, what we're going to do, we added together reaction A, B and C to get our balanced equation. So we're going to add together the delta H values now. So it's minus 394 plus minus 572 plus the 250 for reaction C there. So in total, our delta H value for this is equal to minus 716 kilojoules per mole. So we've just added the reactions together to get our final black equation down here. And then we've added together the delta H values for that to give us an answer of minus 716 kilojoules per mole. So you can head back over to Teams now to get your assigned work that you need to complete on this.